Good morning, grade 12s. I'm Mr. Hanacha, a maths teacher from Matthew Posa Secondary School at Bochum in Limpopo province. Okay, right here today, we are going to treat questions on calculus, and then our main focus is going to be on differentiation and the usage of first principle. Okay, here we've got a question. This question is from KZN. It's a mid-examination from KZN, which was written on 2016. Okay, if we check the first question, 1.1, you are given f of x equals to -5 over x. Now, the question says determine f prime of x from the first principles. Okay, we have learned on calculus that if you are given f of x, let's say in the form of x to the power of n, when we differentiate f of x, we write it as f prime of x. F prime of x, it shows that we are deriving. So we are deriving. Therefore, when we derive, we take n, then we multiply the coefficient that is here. But in this case, because it shows that there is no coefficient, our coefficient here is 1. So when we say n multiplied by 1, the answer is n, because any number multiplied by 1 is that number. Then we say x, which is our variable, and then our n minus 1. So this is how we differentiate f of x into f prime of x using differentiation law. Now, if we check on the question, it says use the first principle. Okay, so the first principle, if you check, it has got the derivative of f of x, which is f prime of x. Now, because you are looking for the first principle, because they say from the first principle, it means that we must check again. We must again check the definition of the first principle. The first principle says f prime of x is equals f of x plus h minus f of x, the limit when h approaches 0, all divided by h. Grade 12, so you're going to get this formula from your formula sheet. So if we have this, but if you check from the definition or from the formula itself, it has got f of x plus h and f of x. So literally it means that what we have here already from the question itself, if they're saying that our f of x is equals -5 over x, this is the same. The f of x that is here is going to be substituted by that. And then now, what it means is that in place of x, in place of this variable of x, we can now substitute x plus h. So that will give us the formula for f prime of x. So what we can do here is that we again say f prime of x is the limit. Never forget to write the limit when h approaches 0. Now, where do we get this f of x plus h? We are now going to substitute the value of x with x plus h. So it means that our f of x plus h. So every time where we see h on this equation, we must put x plus h. This is negative 5 over x plus h. Where there was x is now x plus h. So it means that in place of f of x plus h, we are now going to substitute it with 5 divided by x plus h. So we're going to write it here, minus 5 over x plus h. So this minus 5 over x plus h, it represents the whole f of x plus h. Now here we also have a negative. We have a negative now, but we were given f of x. We're given f of x as negative 5 over x. So we must write it as it is, but remember to put bracket. It's negative 5 over x. They say that everything must be divided by h. So our denominator is h. So once we are done here, so we must work out the numerator. But now we say the limit when h approaches 0 of negative 5 x plus h plus 5 over x, everything divided by h. This is because why we have positive a is because negative multiplied by another negative, the answer is positive. Now, moving further, we have limit when h approaches 0 of, now if you check here, we have got x plus h and x as our denominators. We have the denominators. Our denominators is x plus h and x. Therefore, what we need to do in this case is that we are going to take x plus h, which is this one, and we also multiply it by x. So now it means that on our denominator, we no longer have x plus h plus x, but we're going to have x plus h into x plus h. This is because x plus h here and the x there are called the LCM, the lowest common multiples, or LCD, the lowest common denominator. So we multiply both together, but now we say, okay, because we said this is x plus h multiplying x, they must be divided, but everything must be divided by h. Now we come to this one. Do we have x plus h here? Yes. Do we have x plus h here? Yes, we have x plus h. How many times does this x plus h goes into this x plus h? It goes one time. But if you check, if we say x plus h and x plus h goes one time into each other, on the part of denominator, we're gonna remain with x. This x must multiply that 5. Therefore, we have negative 5x plus Now, we still have x here, but x goes one time into x and x plus h is remaining. Then whatever that remains after this one goes into this must multiply this 5. Then we have x plus h. This must all be divided by h. Now, when the limit h approaching 0, now we multiply in everything that is in the part of our numerator. We have negative 5x plus the 5, because it's a common factor, will multiply x, and again 5 will multiply that h. Then at the end of the day, we will have 5x plus 5h, all divided by our x plus h into x, but they must all be divided by h. Now, because we have this, we can now cancel the ones that looks exactly the same based on their signs. Negative 5x plus 5x is the same as negative 1 plus 1, which means negative 1 plus 1 is the same as 0. Then what is remaining is 5h over x plus h into x. Then, because we have two division lines and we know that this is the same as over 1, so we must change this division into multiplication. So when the division sign changes into multiplication, it means that even h over 1 must change. 1 must come on top and h must come at the bottom. So at the end of the day, we're going to have 1 over h. And because we are multiplying, the denominator of h and the numerator of h will now cancel each other. Then at the end of the day, we have the limit when h approaches 0 of 5, because 5 multiplied by 1 is 5, and x plus h into x. Then because this one cancelled, it means that it's no more, but what is remaining is 1. 1 is the only value that is remaining. Then when we multiply this with 1, the answer is still the same. Now, from there, because we have this, we can now leave the limit when h approaches 0. It means that where we see h, we are now going to put 0. It means that our 5 will be x plus 0 into x. Then our answer is 5. On top, then what is x plus 0? Is the same as x and x. Then the final answer will be 5. What is x multiplied by x? Is x squared. So this means that the f prime of x from the first principle, the answer is 5 divided by x squared. Now, this is a question where they requested that we use the first principle. Now, from here, let's check another question, 1.2. So if you go back to our question, it says determine dy over dx if y is equals to bracket x squared plus 3 bracketed root of x. Now, you check this question it is a question based on the principles of differentiation on calculus. So let's go to our screen. So it says determine number 1.2.1. Then number 1.2.1, it said dy over dx if y is equals, it said x squared plus 3 and then root of x. So this question ranges 4 marks. Now we need to apply the rules of calculus in order for us to determine dy over dx. Now, let's take this equation of y and then work it out first before we can do our derivative, before we can derive. When we say y is equals to x squared plus 3 root of x. Remember that in this case, root of x is a common factor to this bracket. And therefore, this means that we need to change the square root of x into an exponential form. And then we know that root of a is the same as a to the power of 1 over 2. So according to the laws of exponents, because this is an example of a surd. Now, our y is equals to x squared plus 3 x to the power of 1 over 2. Now, because x to the power 1 over 2 is a common factor of x squared plus 3, this means that we must multiply in x to the power of 1 over 2 must multiply 3, and x to the power 1 over 2 must also multiply x. So in this case, if we start with x to the power 1 over 2 multiplying x squared, we say we have y is equals to x squared multiplied by x 1 over 2 plus 3 multiply x 1 over 2. According to the laws of exponents, when multiplying powers of the same basis, we add the exponents. So this means when we have a squared multiplied by a cubed, the answer must be a to the power 5. Because when we multiply powers of the same basis, we add the exponents. So 2 plus 3 is 5. A, because it's a base, it remains as a. So even here, because we are multiplying powers of the same basis, our base will remain as x. But what is 2 plus 1 over 2? 2 plus 1 over 2 will be 5 over 2. 2 plus 1 over 2 is the same as 5 over 2. Plus, now when we come to this one, we don't have same base. But because we are multiplying, it means that this is the same as 3x 1 over 2. Now you remember the law that I showed you at the beginning of the session, where it said when you have f of x given as x to the power of n, then when you differentiate this, it becomes n must multiply the coefficient that is there, which in this case is going to be n. N must also come back, the very same n must also come back and subtract 1, which in this case our x will be n minus 1. So now, if we do the very same thing, if we apply the very same principle on this question, this means that we are going to have, because now we are done simplifying this, instead, we are no longer going to write y. Agree, this one was y. But now, because we want to apply this law, we no longer y, but now we are going to instruct to do what? To differentiate. Now, instead of y, we write dy over dx. Then we say is equals. Then what is 5 over 2 multiplied by the coefficient that is here? We said that because there is nothing here, there is nothing that is written here, we always know that the coefficient there is the value of 1. So 5 over 2 multiplied by 1 is the same as 5 over 2. Then we have our variable of x. What is 5 over 2 minus 1? So 5 over 2 minus 1, 5 over 2 minus 1. 5 over 2 minus 1 is the same as 3 over 2 plus 1 over 2 1 over 2 multiplied by 3. The answer is 3 over 2. Then our variable is x. 1 over 2 minus 1. The answer is negative 1 over 2. Now, when we have this, we can write it in the form of 5 over 2, because this is 3 over 2. This one, it represents the exponent of x. And this one, it represents our root, our square root. Because it's 2, we will say is a square root. But if it was 3, we were not going to write square root, but we are going to write cube root. So now, because we said 2 represent the square root, it means that we put a square root first, then our x, and we said 3 represent the exponent of x. Then we have cube. Plus, this side, we have 3 over 2. According to the laws of exponents again, a to the power negative 1 can be written in the form of 1 over a. But because our x here has got a negative, we are not much concerned about the number, but we are much concerned about the sign. Because there is a negative, it means that we can write it as 1 over x to the power of 1 over 2. So 1 can end here, or 1 can proceed. This is the same as 5 over 2 root of x cubed plus 3 over 2. We mentioned something here that root of x is the same as 1 over 2. So it means that here, because you've got x to the power 1 over 2, we can say it's the same as root of x. Hence, we said this one will represent the exponent, and then this one will represent our square root. Then this will be our final solution. Okay. From here onwards, we will get 2 more questions for part 1 and then be able to complete at least 2, 3, 5 problems. Here we're still on the first question, then we'll proceed with the other one in the next session.